Assalamualaikum warahmatullahi taala wabarakatuh. This is the second video for lecture 3. Let's continue with Hund's rule. So Hund's rule states that when electrons are added to the orbital of equivalent energy, which is also known as degenerate orbitals, each orbitals are filled singly with electron of the same spin first before it is paired. For example, let's take a look at the orbital diagram of carbon atom. So carbon has 6 electrons. So the 2 electron fill in 1s orbital first, so 1s2, 2s2, and the remaining electron will be filled in 2p orbital. So please note that this 2 orbital diagram is different in how the electron is arranged in 2p orbital, which is 2p is the degenerate orbital. So this orbital diagram above is the correct orbital diagram according to Hund's rule, since the electron is filled singly with parallel spin before it is paired. Then the orbital diagram below is not acceptable because it disobeys Hund's rule. Let's take a look at another atom. For example, nitrogen here, it has 7 electrons. So 7 electrons, the first 2 electrons in 1s orbital, so 1s2, 2s2, and the remaining 3 electrons will be filled in 2p orbital singly, 1, 2, 3, before it is paired. So oxygen has 8 electrons, so it will fill in 1s orbital, 1s2, 2s2, and the remaining 4 electrons will be filled in 2p orbital according to Hund's rule. Singly first, 1, 2, 3. And the 4th electron will be paired up with the first electron in this 2p orbital with different spin. So same goes to fluorine atom with 9 electrons, 1s2, 2s2, 2p, 5. And neon with 10 electrons, 1s2, 2s2, 2p, 6. Now, let's do some activity together. So determine whether the following orbital diagrams are acceptable for an atom in a ground state. So explain the mistake and then draw the correct orbital diagram. So this is the first orbital diagram. We have 1s2, 2s2, and 2p2. So this orbital diagram is acceptable because it follows all the 3 rules, the Aufbau principle, the Pauli exclusion principle, and the Hund's rule. Now the second orbital diagram. We have 1s2, 2s2, and 2p3. So this orbital diagram is not acceptable because if you take a look at the 2 electron into s, so this arrangement disobey Pauli exclusion principle. Okay, because no 2 electron can have the same set of quantum numbers. So here the 2 electron into s has disobeyed Pauli exclusion principle. Okay, the third orbital diagram, we have 2s2, 2p, 4. So this orbital diagram is not accepted because the first orbital, which is the lowest energy orbital, 1s, must be filled in first, okay, before the electron is filled at the higher energy of orbital. So this orbital diagram disobey Aufbau principle. Okay, the fourth orbital diagram. So this orbital diagram also is not acceptable because it disobey Hund's rule. So the 3 electron must be arranged in 2p orbital singly with parallel spin first. Okay, the fifth orbital diagram is also not acceptable. Okay, if you notice that in 2s orbital, which has lower energy than 2b, it is half filled with electron. So the 2s orbital must be filled in with full electron, 2 electron, before the remaining electron is filled in 2p orbital. So this orbital diagram does not obey Aufbau principle. And this, the last orbital diagram, is also not acceptable Because if you notice here, this orbital diagram, the arrangement in 2p orbital does not obey Hans' rule, because Hans' rule said that the electron must be filled in degenerate orbital singly with parallel spin before it is paired. So as a conclusion, Aufbau principle states that electrons are arranged in its atomic orbital in order of increasing energy, which is from 1s, 2s, 2p, 3s, 3p, 4s, 3d, 4p, and 5s. So Hans' rule says that when electrons are placed in a set of orbitals with equal energies, which is the degenerate orbitals, the electron must occupy singly with parallel spin before they occupy the orbitals in pair. And last, the Pauli exclusion principle. No two electrons in an atom can have the same four quantum numbers, which is the n, l, m, and s.
Okay, so let's go through this exercise. The first one, which element is pictured? So what we have to do is, we just have to calculate how many electrons for this element. So here we have 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. So maybe we want to refer to our periodic table. Element with 10 proton number or 10 electron is neon. So the answer should be neon. Move on to the next question. Which element is depicted from this orbital diagram? So the term here is referring to which element is represented from this orbital diagram. So the same thing here, what you should do is calculate for the total number of electrons. So here is 4, 6, 8, 10, 12, 14, 16, and 17. So we might want to refer to the periodic table. What are the elements that have 17 proton number? Means that at its ground state, the number of electron is also 17. So the element is chlorine. So the answer should be chlorine here. Next, for this question, this orbital diagram represent the same thing. 1, 2, 3, 4, 5, 6. So 6 electron. 6 electron should be referring to what element? 6 electron and 6 proton number. So the element is carbon. So the answer should be C for carbon. The next one. What is incorrect about this orbital diagram? So, what do you see that seems abnormal for this orbital diagram? So we notice here that at 2p orbitals, there are 2 electrons allocated at the same degenerated orbitals. So it seems like it does not follow Hans' rule. So my answer should be this one. In the 2px box, there should be only 1 electron in the first 2px box and another one is in the second 2p box. Okay? And the fifth question, electrons occupy orbital of lowest energy first is part of what electron configuration rule. So what rules actually referring to the energy of orbitals? Yes, it should be Aufbau principle. Okay.